Hello dear friends, welcome to my channel. Today's discussion GATE 2017 topology problem. So friends, this problem is very interesting. Let tau u and tau d denote the usual topology and discrete topology. So friends, now the question is, what is usual topology? Okay, this is the one remarkable questions. Okay, so first question is usual topology. Okay, and another is discrete topology. Okay, discrete topology on R. So we need to learn everything and consider the following three topologies. Tau 1 is usual topology on R square. Topology generated by the basis. Okay, tau 2. Okay, where u cross v, u belongs to tau d and v belongs to tau u. On R cross R, tau 3 is dictionary order topology on R cross R. Then we need to prove that tau 3 we need to say that which is correct. Okay, which option is correct. This we need to discuss. So I hope that you can read the total questions clearly. So now the standard basic open set for the usual topology is of the form. So what is usual topology? A standard basic open set for the usual topology is of the form a comma b such that equals to x such that a less than x less than b. Okay, so for each a comma b where a greater than b. Okay, this is the usual topology. Okay, usual topology meaning we have to know. Then we need to know discrete topology. Okay, discrete topology. What is the discrete topology, friends? We need to know discrete topology, and another is indiscrete topology. In topology, a discrete space is a particularly simple example of topological space. Okay, so the discrete topology is the finest topology that can be given on a set. Every subset is open in the discrete topology, so that in particular the discrete topology on X is defined every subset of X of open, and X is discrete topological space if it is equipped with its discrete topology. Okay, means you know that power set X is tau is power set of X. Okay, tau is the collection of the power set, because I have already discussed in my channel what is discrete topology. Now we need to know open set. Open set, what is open set? Open set is x comma tau tau b topological space. A subset of X, A does not equals to phi. B open in tau for all X belongs to A. There exists tau open set. Open set U that is U in tau. Okay, U in tau. So friends, now U in tau such that X belongs to U subset of A. Okay, this is the open set. Now you need to know that r comma tau u. Okay, r comma tau u means usual topology. Okay, so r comma tau u means b equals to, I have already told that this is the this way. So b is equal to base is equal to a comma b, r belongs to capital R such that a less than b. Okay, and a comma b belongs to R. This is the usual topology. Next r cross r b. Okay, r cross r tends to b1 means tau 2 b1 equals to a comma b cross c comma d, proper subset of r cross r, and where a b c d belongs to R, A less than B and C less than D. Okay, clear? Okay, clear. So now discrete topology. What is the tau D? Okay, tau D is the discrete topology. Tau D is equal to discrete topology. So tau D means B2 R comma tau D. Okay, R comma tau D. So B equals to X, where X belongs to R. Okay, and B2 tau 2 means tau 2 is B2 is equal to D into B comma C. So it is X B comma C belongs to R. Okay, where B less than C, because as it is usual topology. Let Z belongs to tau and Z belongs to A comma B. Z1 comma Z2 is equal to A comma B and C comma D. And Z1 cross Z2 belongs to A comma B cross C comma D. Okay. So friends, we see that tau 1 so we see that this is the map, okay, map, and we see this is the R, this is R, okay, R cross R. This point is D and this point is C, and this is A and this is B. So we see that x cross B comma C belongs to tau 1 open but does not equals to tau 2, okay. So friends, in this way we can say that tau 1 does not equals to tau 2, tau 1 does not equals to tau 2, okay, tau 1 does not equals to tau 2. So this option tau 1 does not equals to tau 2, so this is option correct, incorrect. And this option okay, this option is incorrect because tau 1 does not equals to tau 2. This is the rule. We will try to discuss order topology, okay, order on, okay, dictionary topology. So consider the set R cross R in the dictionary order. We shall denote the general element of R cross R by x cross y. To avoid difficulty with notation, the set R cross R has neither largest nor smallest element. So the order topology on R cross R has a basis, the collection of all open intervals of the form A cross B, C cross D, A greater than less than C, B less than D. These two types of interval indicate in figure. The subcollection consisting of all intervals of the second type is also basis for the order topology on R cross R. As you can check, this is the R cross R. C cross D, okay, and Z to Z1, Z comma Z1. So friends, it is the C cross D and A cross D, and this is my total area when, okay. So tau 3, now in the case of the tau 3 is equal to B3, tau 3 is equal to B3 equals to A cross B, okay, C cross D order topology, dictionary topology, and A less than C and A equals to C or B less than D, okay. This is the possibility tau 3, possibility of the B3. So it can be written as, that implies A cross B and A cross D equal to 0 cross, so tau 3 a cross b, a cross d is equal to 0 0 comma b comma d. Okay, b comma d comma b comma d, and x cross b cross c, b comma c is equal to tau 2 open. Okay, tau 2 open set, open set. Okay, you see that it is also, I have already written, it is tau 2 open set but not tau 1. Okay, it is tau 2, tau 2 open set. So reverse that z1 cross z2 to belongs to z1 1 cross minus infinity comma infinity a cross b, a cross b comma c cross d, c cross d, c cross d. So a cross b comma c cross d is also tau 2 open. So what we get? We get tau 3 subset of tau 2. Okay, and hence we can tau 3 equals to tau 2. Okay, you see the two case. So tau 2 is open set, so you see tau 2 is open set. Okay, tau 2 is open set is equal to x cross b, x cross c. Okay, you see this is my, in this graph you can see that x cross b into x cross c, x cross c. So tau 2 is subset of tau 3, and another factor you see that tau 3 subset of tau 2. So we see tau 2 is equal to tau 3. So a comma b, c cross d belongs to tau 3 open. Hence, which option is correct? Now we check that my correct option is this option is correct. Option D is correct. Otherwise, all are wrong. Thanks for watching. I hope I can clear this concept. And please view my total work at a glance that it is helpful for your learning. Okay, you check this and you check we sized more small. Yeah, then you will check all writing. This is my total work topology, based on topology. Thanks for watching.